Okay, so good afternoon to all. Okay, so just I will take the review whatever point we have discussed in the last lecture so that it will benefit us for further parts. Okay, so okay, okay, the name of our unit number 30 is the yes, the unit number 3, that is the production drawing. Okay, production drawing, in that limit, heat and the tolerances. Okay, that is our unit number 3. So in that last lecture, whatever which point we have studied, okay, in that last lecture we have covered the following points, like the we have seen the what is meant by the limit. Okay, then we have also seen what is meant by the tolerances. Okay, then again it having the two types, that unilateral tolerances and bilateral tolerances. Again, limit having two limits are there, one is the upper limit and another is the lower limit. Then how to calculate the tolerance, what is the definition of that tolerance, or we can say what is the formula for the tolerance, how we have to calculate the tolerance range. Then also we have seen the different types of the sizes, the nominal size, then basic size. Okay, basic size and actual size. Okay, also we have discussed here regarding to the deviation. Okay, may I write? Yes.
Yes, sir.
Okay,
Yes, sir.
deviation. I think that much point we have covered in that last lecture. So within few minutes, I will take just a review on that point and then we'll move toward the next points, because these are the very important points. If you are not understood that point, if you have not understood this concept, then again the whatever further points are there, that is the feeds, then whole basis system and shaft basis system. That point it will become difficult to understood. So you have to try to understand this basic concept because these are very important. Okay, so just say first upon I will explain here what is meant by the sizes. Okay, now see, first it is the important size is the basic size. Okay, the important is the basic size. Then what is meant by the basic size in simple language? I'm going to write down here its definition. The basic size is nothing but it is the size of part. Okay, it is the size of part after giving the tolerances. After giving the tolerances, it is the size of any part after giving the tolerance. Okay, after giving the tolerances, it is called as the basic size. Okay, for example, suppose we have taken the example. Okay, suppose 30 mm. Okay, 30 mm. And we are knowing that to manufacture the one of the shaft or one of the hole at the exact that size, it is difficult because of some of the errors are there, so that it is necessary to provide the some amount of the tolerance to that size. And when we are providing the tolerance to that size, then that size it will become the basic size. Means suppose to that 30, I will provided here the tolerances, means we are giving the two permissible sizes, two extreme permissible sizes we are providing here, means plus 0.10 and suppose minus 0.10. Okay, if such type of the condition is there, that time you have to understood that 30 is nothing but our basic size, because here we are providing the tolerance zone. Here we have provided the upper limit and lower limit, and this size, okay, that time we can call that 30 is nothing but our basic size. 30 is nothing but our basic size. So it is correct? Yes. Yes, it is correct or wrong?
Yes, sir.
Okay, then see here what is meant by the actual size. Okay, what is meant by the actual size? The actual size is nothing but it is the size of part after the production. Okay, suppose these are the theoretical. This part is the theoretical, means we have seen here, we have taken the example here, the 30 mm. Means suppose we have to produce the shaft of the 30 mm with the this tolerance zone. Okay, this tolerance zone means suppose our shaft it will be manufacturing at 30.10 mm, or suppose the shaft it will be manufactured at the 29.9 mm. In between this range, okay, that range they have given here, and in between that range, suppose our shaft is the manufacturer, then it will be allowed, it will be acceptable or rejectable. In between this range, suppose we have manufactured the one of the shaft out one of the any component, whether that component it will be acceptable or rejectable in this range.
Acceptable.
Okay, it will be the acceptable because they have given the range here. In between this range, you have to manufacture the any component. That component it will be acceptable. Okay. Now, sir, but suppose actual production we have done, and after that we have measured the size of that component, and the size of that component it will show like this. Means suppose. In between that range, please tell me one of the range. Yes, take one of the range in between that proper range, acceptable range, please tell me. In between that range. Yes, yes,
29.
30.5.
yes.
30.05.
Okay, 30.05. It is acceptable.
Yes, sir.
Okay. If
Yes.
suppose after the manufacturing, the size of that component it will be exact, shows this dimension. Okay, and this is between in this range. This is called as the actual size. म्हणजे आफ्टर प्रोडक्शन केल्यानंतर ह्या रेंज मधली कुठली तरी एक व्हॅल्यू आपल्याला येणार आहे, बरोबर आहे का? जी काय साईज आपल्याला प्रोडक्शन नंतर दाखवणार आहे, इट इज कॉल्ड एज द ऍक्च्युअल साईज. Okay, so understood. Basic size means when we are applying the upper limit, lower limit to the one of the size, then it will become the basic size, and after the production, whatever actual size is coming, and that actual size it should be between that range. Okay, it is called as the actual size. Means the size of part after the production, whatever size it will be showing, it is called as the actual size. Okay, so understood? Yes.
Yes, sir.
Then what is meant by the limit? Yes, what is meant by the limit? What is meant by the limit? The limit is nothing but it is the two permissible sizes. It is the two extreme. It is the two extreme permissible. It is the two extreme permissible sizes. Why it is called as a two? Means we are providing the two range. Okay, in upper side and lower side also. Okay, maximum, sorry, extreme म्हणजे जास्तीत जास्त काय असेल ते permissible. Means suppose for example we will take here one of the example. Okay, suppose I'm going to take here one example. Suppose we have to manufacture the shaft of size 25 mm, and here for that 25 mm I will give here the range. Okay, acceptable two range I will provide you. Okay, acceptable two range I will provide you like this. If I have provided the range like this, plus 0.02 mm and the minus 0.01 mm. Okay, means we have provided two range. In between that range only you can produce the product, and if you have produced the any component in between this range, then it will be acceptable. Then how to calculate the upper limit? What is the upper limit? See, it is called as the basic size, na? Yes, it is called as the basic size. Barabar hai ka?
Yes.
That 25 is nothing but your basic size, and here it is called as the that plus 0.02, it is called as the maximum permissible limit. Sorry, maximum permissible size. It is the maximum permissible size. It is the maximum permissible size, and it is the minimum permissible size. Then how to calculate the upper limit? That upper limit, दोन लिमिट दिलेत आपल्याला ना. Then upper limit is equal to, upper म्हणजे काय, maximum permissible size. Okay, Then how to calculate this upper limit? That 25 plus 0.02. What is this? Yes, it will become 25.02 mm. And what is the lower limit here? What will be the lower limit? That lower limit is equal to 25 minus 0.01. Then it will become the 24.99. Okay, like this. Okay, and what is the range they have given here? In between that only 25.02 mm to 24.99. That is the upper limit, upper range दिली आपल्याला, हे lower range दिली आहे. आणि आपली बेसिक साइज एक्झॅक्ट काय असणार आहे? Yes, what will be the basic size?
25.
25 mm इथं असणार आहे, बरोबर आहे का? ओके, जर तुमचा एक्झॅक्ट 25 mm ला जर प्रोडक्ट मॅन्युफॅक्चरिंग झाला, इट इज गुड. ओके, जर ह्या ठिकाणी झाला, अगेन इट इज ऍक्सेप्टेबल, ह्या ठिकाणी झाला ऍक्सेप्टेबल, ह्या ठिकाणी झाला ऍक्सेप्टेबल, अप टू दिस वी हॅव टू मॅन्युफॅक्चर, अगेन इट इज ऍक्सेप्टेबल. जर तुमचा प्रोडक्ट निगेटिव्ह राहिला, हे प्लस साइड आहे ना, here it is called as the this line. You have to remember this line, it is called, but there, that line we will explain later on. Just you have to remember that 25 is the basic size. Above the 25 there will be positive side, and below the basic size it will be negative side. जर समजा आपला प्रोडक्ट इथे मॅन्युफॅक्चरिंग झाला, अगेन इट इज ऍक्सेप्टेबल, अगेन इट इज ऍक्सेप्टेबल. मला सांगा, जर आपला प्रोडक्ट 40.97 ला मॅन्युफॅक्चर झाला, इट विल बी ऍक्सेप्टेबल और रिजेक्टेबल?
Rejectable.
It will be rejectable. And suppose our product it is manufactured at the 25.03 la, again it is acceptable?
Rejectable.
It will be rejectable. Okay, in this range only we have to manufacture. In this range only we have to manufacture. It is called as the limit. Means limit is nothing but it is two extreme permissible sizes. What that permissible sizes? See, this is the one permissible maximum. It is the maximum permissible size. It is the minimum permissible size. It is also called as the upper limit and the lower limit. Okay, means how we can write the definition for that? How we can write down the definition for upper limit and lower limit? Yes, the upper limit, okay, the upper limit is nothing but it is the maximum permissible size. Maximum permissible size. And the lower limit is nothing but it is the, yes,
Minimum.
minimum permissible size. These are the very simple definition. We have prepared our own. Okay, so understood upper limit, lower limit and limit. Then our next point is the tolerance. What is meant by the tolerance? Yes, in our simple language, how we can define the tolerance? Yes,
Difference between maximum.
no, it is the formula, it is the simple formula. Just tell me in the word definition in simple language. The tolerance is nothing but it is the permissible variation. Permissible variation म्हणजे ह्या रेंज मध्ये तुम्ही जर एखादा प्रोडक्ट बनवला ह्या रेंज मध्ये, तर इट इज ऍक्सेप्टेबल. मीन्स सिंपल हाऊ वी कॅन डिफाइन हियर द टॉलरन्स इज नथिंग बट इट इज द permissible range, permissible size range. Okay, म्हणजे फॉर एक्झाम्पल सपोज as the example we'll take here like 25, okay, plus 0.02 minus 0.01. Okay, then first you have to write down here your basic size. What is the basic size? Basic size is nothing but it is the exact size. बरोबर आहे ना? बेसिक साइज म्हणजे आपल्याला काय दर्शवते? एक्झॅक्ट साइज थोडक्यात. ओके, what is the basic size here?
25.
Okay, now see here 25 is nothing but our basic size, 25. Then calculate the upper limit. Yes, what is the upper limit?
25.02.
25.02 is the upper limit. Then calculate the lower limit. It is equal to 44.90. Okay, it will be the lower limit. Then okay, this is the range. बट व्हॉट इज दिस टोटल परमिसिबल रेंज इज देअर. टोटल किती रेंज झाली आपल्याला काढायची. इट इज कॉल्ड एज द टॉलरन्स. टोटल रेंज किती mm आहे ते आपल्याला कॅल्क्युलेट करायचं. इट इज कॉल्ड एज द टॉलरन्स. देन आय एम गोइंग टू राइट हियर दॅट टॉलरन्स is equal to, this is the formula, upper limit minus lower limit. Then write down their value here. Upper limit 25.02 minus lower limit, it is the 24.99. And what is the permissible range? What is the this permissible range is there? It will be the 0.03 cm. Okay, that much variation is allowed. That much variation is permissible. That much variation it will be accepted. जर तुम्ही मॅन्युफॅक्चरिंग एखादा कंपोनंट प्रोडक्ट करत असाल आणि त्या मॅन्युफॅक्चरिंग मध्ये त्या प्रोडक्शन मध्ये जर एवढं व्हॅरिएशन आलं म्हणजे आपल्याला त्यांनी थोडक्यात एक्झॅक्ट साईज किती सांगितलेलं आहे ठिकाणी, किती mm चा प्रोडक्ट त्यांना ऍक्च्युअली अपेक्षित आहे. येस, 25 एक्झॅक्ट एवढा आहे. जर ह्याच्यात प्लस मायनस झालं तर कितीचं व्हेरिएशन झालं पाहिजे, ह्या 0.03 mm चं व्हेरिएशन झालं पाहिजे. अप्परला होऊ द्या किंवा लोअरला होऊ द्या. दॅट मच व्हेरिएशन इज अलाउएबल. दॅट मच व्हेरिएशन इज द परमिसिबल. दॅट range of variation, the range of variation is nothing but your tolerance. So understood? Yes, yes,
sir.
okay. Suppose if your variation it will be varies from this 0.03, then it will become like this 0.04. Then again it is acceptable. No, it will be rejected. Your project it will be rejected. Okay, product it will be rejected. So understood? Limit and tolerances. So understood? Yes.
Yes, sir.
Okay. Then here the next part is deviation. Okay. Again, it is very important part. Deviation. Okay, deviation. Then tell me shortly what is meant by the deviation.
Difference between actual size and basic size.
Okay, it is the
Difference
between
actual size and basic size.
okay, actual size and basic size. Okay, actual size and basic size. Like this. Okay, the deviation is equal to actual size minus basic size. Okay, so it is called as a deviation. What is meant by the deviation? Simple. Deviation म्हणजे कितीचा फरक पडला actual size पासून. Okay, for example, suppose 25 is nothing but our actual size. Sorry, 25 is nothing but our basic size. Okay, just I will take the example so that we will understood properly. Simple, just you have to remember this formula how to calculate the deviation. Okay, so for example, take example it will be like this 25 mm. It will be our basic size. Okay, it will be the basic size is there. Okay, and suppose okay during the manufacturing we are knowing that to produce that exact size it is not possible. Okay, and after the manufacturing, okay, after the manufacturing that basic size it will be varying and the actual size it will be like this 25.05. Then how to calculate it? See here actual size किती आली या ठिकाणी आपली या ठिकाणी 25.05 आलेली आहे आफ्टर द मॅन्युफॅक्चरिंग. आणि आपण एक्सेप्ट एक्झॅक्ट साइज किती केली ती म्हणजे आपली बेसिक साइज किती आपण ठरवली त्या ठिकाणी 25. Then what is the difference between that two values? It will be the 0.05. Okay, it is correct.
Yes, sir.
So it is called as the deviation. म्हणजे 25 पासून किती डेव्हिएट झाला हा कंपोनंट, किती mm ने डेव्हिएट झाला, किती mm ने डेव्हिएट झाला तर हे यस किती mm ने झाला डेव्हिएट
0.05.
म्हणजे बघा या ठिकाणी आपल्याला एक्झॅक्ट कितीची अपेक्षा होती 25 mm. ओके, पण ऍक्च्युअल मध्ये किती तयार झाला, ऍक्च्युअल मध्ये तयार केला तर त्याची साईज किती आली, तर शाफ्टची होलची आपल्याला 25.05. म्हणजे मला सांगा ह्या दोन्ही साईज मध्ये कितीचं डेव्हिएशन आलं आपल्याला, 0.0. It is called as the deviation. So understood?
Yes, sir.
Yes. Okay. So again, there is the types of the deviation. Okay, main types of the deviations are upper deviation and lower deviation. Okay, upper deviation and the lower deviation. Then what is meant by the upper deviation and what is meant by the lower deviation? Yes, yes, first tell me what is meant by the upper deviation. Yes, पार्ट झालता का आपला? Yes, please. What is meant by the upper deviation and what is meant by the lower deviation? Yes. Please tell me. Yes, anybody? Now see here, the upper deviation is nothing but it is the algebraic difference between maximum limit. Okay, maximum limit of size. Maximum limit of size. Maximum limit of size. Maximum limit of size and basic size and the basic size. Okay, the upper deviation. Okay, the upper deviation nothing but it is the difference between maximum limit of size and basic size. The maximum limit of size minus basic size. आता इथे मला सांगा मॅक्झिमम लिमिट साइज म्हणजे काय आपण याला काय म्हणू शकतो? यस, हॅलो हॅलो, मी ऑडिबल?
Yes, sir.
Yes, sir.
टेल मी ना. हा, मॅक्झिमम लिमिट ऑफ साइज मीन्स व्हॉट?
Upper limit.
Okay, it is the upper limit, simple. Upper limit minus basic size. You can easily calculate it is the basic deviation, upper deviation. Means for example, yes, anybody? Okay, means suppose we'll take here same example again. Okay, suppose 25. Okay, 25 plus 0.02 minus 0.01. Okay, then tell me here is the upper limit. That 25 is indicate the it is the
Basic size.
Basic size.
Size.
and where is the upper limit? 20.0. It is correct.
Yes.
Sir.
This is the upper. Then how to calculate the upper deviation? Tell me. 25.02
25.02
minus.
25.
What is the answer? What is the answer?
0.02.
0.02 is the upper deviation. The 0.2 is the upper deviation. Okay, so understood. And what is meant by the lower deviation? Yes, cash low. Yes.
Minimum size and basic size.
Basic size.
So I will write down here. Just try to understood. Okay, the lower deviation is nothing but. Okay. So lower deviation is equal to, yes, minimum limit of size, na? Minimum limit of size minus basic size. The minimum limit of size means what? It is the lower limit, na?
Lower limit.
Then lower limit minus basic size.
Basic size.
Okay. Then tell me here, take the same example again. Please tell me. Then lower deviation is equal to what is the
20.
minimum limit?
24.99.
Calculate here. Yes. Yes. See, this is the maximum limit. Sorry, this is the maximum limit of size. This is the minimum limit of size. Then this is the upper limit I have calculated. And then what is the lower limit? Lower limit is nothing but 25 minus that 0.01. It will be the, yes,
20.
24.
0.99.
Then 24.99 we have taken as the lower limit minus basic size. It will be same 24. Then what is the answer for that?
0.0.
Yes, minus or plus?
Minus.
Minus. Yes, minus 0.01.
0.1.
0.1.
It will be the lower deviation. Okay. Then how to show that upper deviation and lower deviation here in graphical representation? In that, with the help of the graphical representation, just yeah. So just you have to remember that value for the upper deviation and lower deviation. So here at this corner, I will write down here. That is the upper deviation. I will write down the upper deviation. What is the value for upper deviation? It will be 0.2 mm, and the lower deviation, it will be the minus 0.01. So that top value, that two value we have to remember. Okay. And that remaining part I will erase here. Okay, now just I have to remember. Okay. Then I will explain here next concept so that we will show graphically. Okay, so what is meant by the zero line? What is meant by the zero line? That point we have covered in that last lecture. Yes or no?
No.
What is yes or no? Yes. Okay. So just concentrate here. Zero line. Okay, zero line. Sorry, zero line. Zero line. And what is meant by the zero line? The zero line is nothing but, okay, the zero line is nothing but it is the graphical representation of the basic size. Okay, it is the graphical representation. It is the graphical representation of basic size. It is the graphical representation of the basic size, and the next point, it will be important point. Your zero line, it will show the zero line. It will show, it shows exact basic size. Okay, exact basic size. म्हणजे थोडक्यात काय सांगायचं आपल्याला, झिरो लाईन म्हणजे कशाची साईज दाखवतो झिरो लाईन आपल्याला? Zero line, it will show the exact basic size. Okay, just a minute. Suppose one line I'm going to draw. See, this is the line. Okay. So this is the line. Okay. Suppose this is our zero line. Okay. What is meant by the zero line? Zero line is nothing but it shows the graphical representation of the basic line. Okay. This is the graphical representation of the basic line, and again the important part, that point you have to remember, that zero line, it will show the exact basic size. म्हणजे ह्या ठिकाणी माझी कुठली साईज असणार आहे मला सांगा प्रथम. या ठिकाणी कुठली साईज मी दाखवणार आहे? बेसिक साईज दाखवणार आहे की एक्झॅक्ट साईज दाखवणार आहे? सॉरी, बेसिक साईज दाखवणार आहे का ऍक्च्युअल साईज दाखवणार आहे? या ठिकाणी ह्या लाईनच्या एकदम ह्या लाईनला मी काय कुठली साईज दाखवणार? This is called as the zero line, and remember this sentence, that zero line, it will show the exact basic size. म्हणजे in this example, what was our basic size?
25.
25. मला सांगा, मी 25 कुठे दाखवू आता? या लाईनच्या बरोबर दाखवू, वरती दाखवू, खालती दाखवू?
लाईनच्या बरोबर.
बरोबर आहे, म्हणजे इट विल इंडिकेट द 25. म्हणजे थोडक्यात ही लाईन तुमची काय दाखवणार आहे, एक्झॅक्ट बेसिक साईज दाखवणार आहे. बरोबर आहे का? बरोबर आहे.
हो.
Okay, and the next point is the upper side of that line. Okay, this upper side of that line, it will be the positive side, and below this line it will be the negative side. It will be the negative side. You have to remember. Okay, upper side it will show the positive, and the below side of this your line it will be the negative. Okay, understood? आता मला सांगा, आपल्याला डिव्हिजन फाइंड आउट करायचे. ओके, डिव्हिजन फाइंड आउट करायचं म्हणजे एक्झाम्पल आपण काय घेतलं होतं, 25 प्लस यस प्लस 0.02 ना, प्लस 0.02 मायनस 0.01. ओके, हे आपलं एक एक्झाम्पल होतं. अकॉर्डिंग टू दॅट वे ऑफ मॅन्युफॅक्चर द कॉम्पोनंट. ह्याचा बेस घेऊन आपल्याला काय करायचं होतं, एखादा कॉम्पोनंट आपल्याला मॅन्युफॅक्चर करायचं. ओके, आता ह्या रेंजनुसार मी मॅन्युफॅक्चरिंग चालू केलं, कॉम्पोनंट चालू केलं, आणि आपल्याला अपेक्षित किती असतं, 25. एक्झॅक्ट यावाही सगळीची अपेक्षा असते ना आपल्याला, बरोबर की नाही? ते म्हणजे व्हॅरिएशन आहे, पण एक्झॅक्ट येणं सोपं आहे का? नाही, इट इज डिफिकल्ट ड्यू टू सम एरर्स. Okay, and after the manufacturing according to that tolerance zone, the size of our component it will be, okay, it will be the 25.02. It is acceptable? It is acceptable?
Yes.
Yes.
म्हणजे आपले बेसिक साइज किती सांगते आपल्याला, किती न कंपोनेंट आपल्याला मॅन्युफॅक्चर व्हायला पाहिजे. Our basic size is nothing but exact size 25. But after the manufacturing, what is this? This is called as the actual size. किती आलेले actual size? 25.01. Okay, मग कुठे येईल हे लाईन? हे 25.01. Here it will be shown in above side or below side?
Above.
Okay, means nearly about, suppose it will be like this. Here, suppose 20.01. Okay, समजा परत आले आपले किती, 20.02. 20.02 actual size. Okay, now see, these are the deviation. So this is the deviation. These are the deviation. म्हणजे ह्या बेसिक साइज पासून तुमचा actual size किती डिव्हाइड झाली, it is called as a deviation. And suppose, okay, suppose sometime it will come into negative also, na? Sometime it will be negative. Suppose 20 point, yes, कशी येईल नेगेटिव्ह मध्ये, 24.99. then how I have to show? हे 20.99 हे कुठं दर्शवलं पाहिजे आपण, बेसिक साइजच्या खाली का वरती येईल?
खाली.
खालती येईल ना, बेलोला येईल ना. 24.99 मायनस मध्ये गेले, बेसिक साइजच्या मायनस मध्येच गेलो ना आपण. एक्झॅक्ट ही मला पाहिजे होते, एक्झॅक्ट हे पाहिजे होते, त्याच्यावरती गेलं तरी प्लस मध्ये झालं ना. 25.01 25.0.23 ती ऍक्सेप्ट ही झाली म्हणायचं, अप्पर साइड झाली म्हणायचं. ओके, म्हणजे दॅट 24.99 it will be the negative. So this is called as the lower deviation. हे तुमचं लोअर डिव्हिजन झालं, हे तुमचे अप्पर डिव्हिजन. समजतंय का? यस.
Yes.
Sir.
So understood? Zero line is nothing but it is the graphical representation of the basic size, and that zero line it will showing the exact basic size. ह्या लाईनवर आपण काय दर्शवणार आहे, नेहमी एक्झॅक्ट साइज असणार आहे, बरोबर आहे का? म्हणजे फॉर एक्झाम्पल बघा, आता मी या ठिकाणी डॉट देतो, हे तुमची किती आहे, 25 ची लाईन आहे. ओके, म्हणजे इथं आपल्याला एक कॉम्पोनंट मॅन्युफॅक्चरिंग झाला, दुसरा या ठिकाणी झाला, तिसरा या ठिकाणी झाला, चौथा या ठिकाणी झाला, पाचवा या ठिकाणी झाला, सहावा या ठिकाणी. म्हणजे आपलं व्हेरिएशन कसं आलं बाळांनो, लाईक दिस. लाईक दिस व्हेरिएशन. सो इट इज कॉल्ड एज द डेव्हिएशन्स. समजतंय का? म्हणजे हे तुमची बेसिक लाईन जर असेल, सपोज दिस इज द बेसिक लाईन, और वी कॅन से द झिरो लाईन. ओके, आणि आपला कॉम्पोनंट कसा मॅन्युफॅक्चरिंग होत चाललाय, पहिला कॉम्पोनंट ह्या ठिकाणी झाला, दुसरा ह्या ठिकाणी झाला, तिसरा ह्या ठिकाणी झाला, चौथा ह्या ठिकाणी झाला. म्हणजे पहिला कॉम्पोनंट या ठिकाणी मॅन्युफॅक्चरिंग झाला, दुसरा लाईक दिस, तिसरा लाईक दिस, चौथा लाईक दिस, पाचवा बरोबर इथं झाला, सहावा इथं झाला, सातवा इथं झाला, आठवा इथं झाला, नववा इथं झाला. These are the deviations. Understood? Yes or no?
Yes, sir.
Okay. Okay. So again, next small part is remaining. The types of the tolerances. Okay. Types of tolerance. And what are the different types of the tolerance? Okay. Types of tolerance. Please tell me faster. What are the different types of the tolerance?
Unilateral and bilateral.
Okay. Unilateral. Okay. And second will be the bilateral. Then tell me what is the meaning of that uni word and what is the meaning of that bi? Bi means two. Uni means one. It is correct? It is correct or wrong? Yes, please. Yes. Uni means one, na? Unit, one. And bi means two. Yes or wrong?
Yes, sir.
Okay. Then what is meant by the unilateral tolerance? Please tell me first. What is meant by the unilateral tolerance? What is the definition for that? Yes. Please, anyone? What is meant by the unilateral tolerance? Yes. Yes, anyone? What is meant by the unilateral tolerance? Already I have explained that point, na? Yes. Okay. Now see, the unilateral tolerance is nothing but when we are showing the tolerance zone. Okay, when we are showing the tolerance zone on only one side, on okay. What is meant by that unilateral tolerances? Yes, the unilateral tolerance is nothing but when we are showing when the tolerance zone we are showing on only one side of basic size. Okay, when we are showing when we are showing the tolerance zone of the parts, when we are showing the tolerance zone of the part only one side of basic size, only one side of basic size. Okay, it is called as the unilateral tolerance. Okay, means in a simple language also I will tell you, the unilateral tolerance is nothing but when we are showing the dimension of the part on only one side of the basic size. Means what? Yes, only one side of the basic size. Suppose 25 plus 0.02. Okay, again plus 0.0. See, this is the basic size. What is the basic size? 25 is our the basic size. Okay, yes, 25 is our the basic size, and we are showing the dimension on only one side. Means either we have to show on the positive side, and okay, and again we have to show only on the negative side. जर मी ह्या पार्टची डायमेन्शन ह्या बेसिक लाईनच्या कोणत्या तरी एकाच डायरेक्शनला दाखवतो, एखाद्या तर प्लस डायरेक्शनला दाखवतोय किंवा मायनस डायरेक्शनला दाखवतोय, दॅट सिस्टम इज कॉल्ड एज, और दिस टाइप ऑफ टॉलरन्सेस are called as the unilateral tolerances. See, this is the example. Suppose another example is 30 plus 0.01. Okay, again plus 0.0. Whether it is unilateral or bilateral? Yes.
Unilateral.
Why it is
Unilateral.
why it is unilateral? because see, this is the basic size, and the tolerances are were showing, or the sizes, that permissible sizes were showing on the only positive side. Yes, only positive side. They are not showing the negative side. Okay, only positive side means plus minus आपण दाखवतो का या ठिकाणी नाही. We are showing the dimensions on only one direction. Either we have to show on the positive side or either we have to show on the negative side only. म्हणजे दोन्हीपैकी कुठल्या तर एकाच साइडला आपण डायमेन्शन दाखवायचे आहे. इट इज कॉल्ड ॲज द युनिलॅटरल टॉलरन्सेस. ओके, अंडरस्टूड? Yes.
Sir.
Okay. And tell me the next example. I will take care of the next example. Okay, suppose. Then tell me 25. Okay, minus here 0.01. Again minus 0.02. Then tell me whether it is unilateral or bilateral.
Bilateral.
Uni.
It is the bilateral. Why it is bilateral?
It is unilateral.
It is unilateral now, where we have to show the dimension of the part on only one side of basic size. See, this is the zero line. Okay, zero line वर काय आपण दर्शवतो, बेसिक साइजेस असते या ठिकाणी. ही झाली एक साइड, ही झाली दुसरी साइड. म्हणजे एक तर तुम्ही पॉझिटिव्हला दाखवा दोन्ही तुमचे साइजेस, किंवा दोन्ही साइजेस तुम्ही कुठे दाखवा, निगेटिव्हला दाखवा. जर तुम्ही दोन्ही साइजेस पॉझिटिव्हला दाखवत असाल तरी पण तो युनिलॅटरलचा आहे, तर दोन्ही साइजेस तर तुम्ही फक्त निगेटिव्हला दाखवत असाल तरी तो युनिलॅटरलचा आहे. समजतंय का? Yes.
हो सर, कळलं.
Yes, sir.
Then tell me next example. See here 25 minus 0.01 and minus 0.00. Then tell me whether it is in your by.
Uni.
Unilateral.
Because here both the permissible sizes we have shown on the negative side. Both the permissible value in this example also we are showing on the negative side. Okay, बरोबर आहे का? Okay, the next example कसं असेल, 25 plus 0.02 plus 0.01. Okay, whether it is unilateral or bilateral.
Unilateral.
Unilateral.
Because both the permissible sizes we have shown on the, yes,
Positive side.
means only one side we have to show. Suppose 30 plus 0.05 again plus 0.04 or 0.21, like this. Again it is unilateral or bilateral.
Unilateral.
Because here see, this is the basic size and the part of that size, the sizes of that part when we are showing on only one side of the basic size. म्हणजे बेसिक साइजच्या अप्परला दाखवा किंवा लोअरला दाखवा. अप्परला असेल तर काय असणार आहे, पॉझिटिव्ह असणार आहे, आणि लोअरला असेल तर काय असणार आहे, निगेटिव्ह असणार आहे. If such types of the tolerances are there, then time it is called as the unilateral tolerances. So understood? Yes.
Yes, sir.
Then how to show that unilateral tolerances in graphically? Okay, in graphically. Okay, how to show the graphical representation of that unilateral tolerances? Okay, just show here. Just okay, suppose I have drawn here one line. This is called as the
Basic line or zero line.
okay, basic line or zero. This is one reference line I'm going to draw. Okay, now see here. Okay, how many examples we have taken here? 1, 2, 3, 4 examples we have taken. Okay, for this example we will show the tolerance. Okay, take the first example, positive side. Okay, see, this is called as zero line, na? Yes.
Yes.
Yes, sir.
This is the zero line, means it shows the basic size. इथं काय कुठली येणार आपल्याला साइज? फॉर एक्झाम्पल 25 असेल. काय तुमची बेसिक साइज असेल. Okay, now tell me what is the tolerance zone for this 25? Yes, what is the tolerance zone?
Minus 0.01.
No, just tell me. Okay, what is the upper limit and what is the lower limit for this? Yes, What is the upper limit here? Calculate.
Minus 0.01.
Just a moment. Yes. What is the upper limit for this? Sharana, 25 minus 0.01. What is the answer for this? Yes,
24.99.
24.90. And here 25 minus 0.02. Yes, tell me. What is the answer?
98.
98.
24.98.
98.
Okay. Then tell me, out of that two, what is the upper and what is the lower? Yes, what is the upper and what is the lower? यातला upper कुठला आणि lower कुठला?
24.99. Upper.
Yes. कसं असेल? upper कुठला असेल आणि lower कुठला असेल? प्रगती. लांबच म्हणजे अप्पर ना, मला सांगा 25 इज द करेक्ट साइज. ओके, आता हे 25 च्या जवळच कुठलं झालं? 25 च्या जवळच कुठलं झालं?
24.99.
इज द जवळच म्हणजे कुठलं लिमिट झालं? लोअर लिमिट ना, मिनिमम साइज झाली आणि मॅक्सिमम किती झाली तुमची जास्तीत जास्त?
24.98.
ओके, मीन्स मला सांगा तर दोन्ही साइज कशा आहेत आपल्या? निगेटिव्ह साइज आहे. म्हणजे upper side of that zero line it will be the positive side and below side it will show the negative side. बरोबर आहे का? बरोबर आहे का? आता मला सांगा ह्या एक्झाम्पल मध्ये दोन्ही साइज आपल्या कशा आहेत? अप्पर लिमिट आणि लोअर लिमिट दोन्ही लिमिट कशा आहेत? निगेटिव्ह आहेत. म्हणून मी काय दर्शवतोय? So this is called as the tolerance zone. This is called as the tolerance zone. So this is the which limit? It is the lower limit and it is the
Upper limit.
Upper limit.
म्हणजे ही व्हॅल्यू किती राहणार तुमची? 24.99 असेल आणि ही व्हॅल्यू किती असेल?
24.98.
बरोबर आहे का? ओके, सी इन दिस मॅनर वी हॅव टू शो. आता मला सांगा नेक्स्ट ह्यासाठी मला दाखवायचं. ओके, हे एक्झाम्पल साठी. Okay, then tell me what is the upper limit for that? Yes,
25.02.
What is the lower limit for that?
25.01.
0 plus, sorry. It is plus, good. इथे किती असेल?
25.01.
20.01 असेल. Then what is the upper limit? आणि एक्झरसाइज आपली किती आहे? 25. 25 च्या जवळ कुठला आहे? हे आहे. म्हणजे हे कुठलं झालं तुमचं? लोअर लिमिट झालं. हे काय झालं? अप्पर लिमिट झालं. बरोबर आहे. हाऊ टू शो? बोथ द लिमिट्स आर इन पॉझिटिव्ह साइड. पॉझिटिव्ह आहेत का निगेटिव्ह आहेत?
Positive.
ओके, म्हणजे आपण कुठं दर्शवला पाहिजे हे?
Above.
We have to show that all limits in upper side of the zero line. Then first up on we have to draw the tolerance zone. So this is the tolerance. Okay. This is the tolerance. Tell me. It is the
Lower limit.
It is the lower limit. What is this? 20.
5.01.
This is the
Upper
upper
limit.
limit 20.10. Now tell me, it is the which type of tolerance system? It is the unilateral. बरोबर आहे का? प्लस प्लस युनिलॅटरल मध्येच आहे ना हे?
Oh.
It is the unilateral, again it is the unilateral. So understood?
Yes, sir.
Yes. We'll discuss. So understood? When we can call the unilateral? When the tolerance zone, or we can say the sizes of the part when we are showing on only one side of the basic size. Either we have to show the dimension in the positive side, or either we have to show both the limit in the negative side. म्हणजे जर दोन्ही लिमिट आपण पॉझिटिव्ह साइडला दाखवले असेल तर it is called as the unilateral. Or again, suppose we have shown both the limit, upper limit and lower limit, suppose we have shown on the negative side, again it will be the unilateral system. It is very simple. Understood? Yes.
Yes, sir.
Yes, sir.
So, okay. Now we will move to the next, that is the bilateral tolerances. Okay. Bilateral tolerances. Then what is meant by the bilateral tolerances? Just you have to make the reverse. Okay. What is the definition? When we are showing
Different
the
side of basic
different.
size.
Means- yes, both the side of when we are showing the tolerance or all the simple language मध्ये आपण कसं लिहू शकतो या ठिकाणी when we are showing the both the limit, upper limit and lower limit, when we are showing the upper limit and lower limit, or both the limit when we are showing both the side of the basic size, when we are showing the tolerance zone sizes on the both the side of basic size, both the side of the basic size, both the side of basic size. Okay, suppose example. Yes, what is the example? Suppose I'm going to here 45. Okay, 45 plus 0.03 minus 0.02. Then tell me what is the that 45 is there. 45 is nothing but our basic size. 45. Then tell me upper limit. Upper limit is the
45.03.
yes 45.03. Then tell me the lower limit. Yes.
44.98.
Okay, so this is it. Then tell me here that upper limit and lower limit we are showing on the both the side of the basic size. म्हणजे basic size च्या प्लस ला आपण दाखवले आणि निगेटिव्ह ला पण दाखवलेला आहे. ओके, इन सच टॉलरन्स सिस्टम इज कॉल्ड एज द बायलॅटरल सिस्टम. जर असं जर असेल प्लस साइडला पण टॉलरन्स दिलेला आहे आणि निगेटिव्ह साइडला पण टॉलरन्स दिलेला आहे. ओके, प्लस मायनस सिंपल लँग्वेज मध्ये जर तुम्हाला प्लस मायनस चिन्ह आलं तर वी कॅन कॉल इट इज द बायलॅटरल. आणि या ठिकाणी काय येणार, फक्त एक प्लस प्लस येणार किंवा या ठिकाणी निगेटिव्ह निगेटिव्ह. आणि बायलॅटरल मध्ये कसं येणार आहे, प्लस मायनस प्लस मायनस. Okay, if such type of the tolerance systems are there, then it is called as the bilateral. Means simple, in that bilateral system we are showing the sizes of part on the both the side of basic size. Okay, now see here, see this is our basic size. What is the basic size here?
45.
45. This is the positive side, this is the negative side. Then tell me how to draw their tolerance zone. Tolerance zone आता कसा येईल या ठिकाणी?
55.03 upper side line.
Means like this. Like this. Suppose okay. Like this. So this is the upper side. This is the lower side. म्हणजे हे किती असणार तुमचा? Yes.
45.03.
असणार आणि हा किती असणार लोअर लिमिट?
44.98.
So this system is called as it is the bilateral tolerances. It is the bilateral tolerance. So understood?
Yes, sir.
Okay, so I will take another example here.
Sir. सर युनिलॅटरल मध्ये एक एक्झाम्पल घेतला बघा सर. 25.0.01 मायनस 0.02 हे एक्झाम्पल आहे ना सर. त्यामध्ये हे चालतंय का सर? बेसिक साईज 25 आहे, मग 25 असेल तर चालतंय का सर?
म्हणजे
बारचं साईज 25 असेल तर ऍक्सेप्टेबल आहे का नाही सर?
ऍक्सेप्टेबल ना.
सर मग टॉलरन्स काढला तर 0.01 येते सर अप्पर साइज लिमिट आणि लो टॉलरन्स सर.
हम्म.
मग 0.01 येते सर. जर ऍक्च्युअल मध्ये टॉलरन्स बघितलं तर 0.02 येते सर.
असू दे काय अडचण ऍक्सेप्टेबल आहे ना रेंज ते, त्याच्यामध्ये तुम्ही किती मॅन्युफॅक्चरिंग करा. आलं लक्षात. जर
नाही सर,
तुम-
मी काय म्हणतो, तुम्ही हे एक्झाम्पल घेतलं ना सर, ह्याचं टॉलरन्स फॉर्म्युला मध्ये घेतलं तर 0.01 येते सर.
हम्म. बरं, ओके.
ऍक्च्युअल मध्ये बघितलं तर 0.02 ह्याचं टॉलरन्स आहे
Your question is not understood. I have not understood your question.
सर. हे जे एक्झाम्पल आहे ना सर, टॉलरन्सचे फॉर्म्युला अप्पर लिमिट मायनस डिफरन्स बिटवीन अप्पर लिमिट अँड लोअर लिमिट हे 0.01 आहे सर. मग ऍक्च्युअल मध्ये टॉलरन्स 0.02 आहे येते की सर इन ऍक्च्युअल.
What actual? In actual means what?
टॉलरन्स सर.
Yes. Yes, Police Patil, we will discuss later. Okay. After that. I will clear your concern. No problem.
ओके सर.
Take next example here for the bilateral tolerances. Suppose 30, okay, plus 0.02 minus 0.05. Okay. Now tell me that 30 is nothing but our basic size. Okay, 30. Then tell me the upper limit here. Upper limit it will be the 30. Yes. Yes, 30.02
02.
mm, and lower limit it will be the
29.95.
95 is the lower limit. Okay. Okay. Now see here in this side, in this example, this is the basic side. I am the two limits. Okay, the sizes of that part it will showing on the both the side. Means we are giving the tolerance on upper side also, we are giving the tolerance on the negative side also. Okay. Okay, so that it is called as the bilateral tolerance. Then how we have to show on the graphically. So this is the basic line, it will indicate the exact 30 mm. Okay, what is the upper limit? It will be the up to the 30.02 like this. It is the upper limit. And what is the lower limit? It will be like this. Okay. Okay, in this manner we have to show graphically. So understood? Yes.
Yes, sir. Yes, sir.
Okay. So this is the simple difference between unilateral tolerances and bilateral tolerances. You have to remember, in the unilateral we are showing the size of part on only one side of the basic size. Either we have to show on the positive side or either we have to show on the negative side. Okay, but in the bilateral tolerances we have to show the sizes of the dimension on the both the side of the basic size. Means we can show the dimension in positive side along with the negative side also. Means both the sign will be there in this bilateral tolerances, but in that unilateral tolerances there will be the either plus sign or either negative sign like this. Okay, so understood? Yes.
Yes, sir.
Okay.
Yes, sir.
Okay, so which part is remaining here? Yes. Okay, then allowance. The one more important part is remaining here, the allowance. What is meant by the allowance? Yes. That's the next point. What is the allowance? Again, it is one important point. allowance. Then what is meant by the allowance? Yes, anybody? Yes, when we can call it the allowance. See here the definition of that allowance is it is the difference. Okay, the allowance is nothing but it is the difference. It is the difference between two mating parts. It is the difference between two mating parts. It is the difference between two mating parts. It is called as the allowance. Okay, difference between two. Sorry, it is the difference between two mating parts. It is called as the allowance. Okay, for example, okay, just I will draw here one example here so that we will understood. Okay, suppose this is the shaft. This is the shaft. Okay, it is the shaft, and suppose it is the hole. This is the hole. Okay, for example, suppose, okay, so this is the shaft, and it is the hole. And suppose the size of that shaft, it will be, the size of this shaft will be there, like this. Suppose the diameter of that hole and the diameter of that shaft, it will be, I will write down the dimension over here. Suppose the size of hole, it will be suppose 24 mm, and the size of that shaft, it will be the 30.5 mm. See, then what is meant by the allowance? Allowance is nothing but it is the difference between two mating parts. Okay, then 24 minus 30.5. Then what is the allowance is here? Yes. What is the allowance?
0.5.
0.5 mm the allowance. It is called as the allowance. म्हणजे समजा, for example, suppose this is the hole. Okay. See, this is the example of the pen. Simply you have to imagine this will be the hole and this will be the shaft. And suppose I have inserted this shaft into this hole. Okay, I have inserted this shaft into this hole. Then what is the difference? What is the size of this hole and what is the size of this shaft? And what is the difference between them? Okay, when that two components are mating to each other. When that two components are mating to each other, and then what is the difference between that both the sizes? ओके, म्हणजे शाफ्टची साइज किती आहे आणि होलची साइज किती आहे आणि ह्यांच्यामध्ये किती डिफरन्स आलेला आहे. व्हॉट इज द डिफरन्स बिटवीन दॅट टू मीटिंग पॉइंट्स लाइक दिस. ओके, यू हैव टू सी दैट इज द डिफरन्स. दिस पोर्शन is called as the allowance. It is called as the allowance. That is the difference, na? That much difference is there, na? Yes, it is correct. Yes or no?
Yes.
It is called as the allowance. It is called as the allowance. Okay. Then again there is the two types of the allowances: positive allowance and negative allowance. Okay, positive allowance and the negative allowance. Then when we can call it the positive allowance and negative allowance, simple. Okay, when the shaft size and if suppose if shaft size is small, if the shaft size is small and hole size is the more. Okay, if the shaft is smaller and hole is bigger, okay, that time it is called as the positive allowance. It is called as the positive tolerance. And suppose example, suppose this is the shaft is there. Okay, and suppose this will be the hole. Means here in this example, shaft is the bigger and hole is the smaller. That time whatever allowance is there, okay, whatever allowance is there, it is called as the negative allowance. It is called as the negative allowance. So understood? What is meant by the positive allowance? Positive allowance is nothing but when shaft is smaller and hole is big or larger. It is called as the positive allowance. And when shaft is the bigger and hole is small, it is called as the negative allowance. So understood? What is meant by the allowance? Allowance is nothing but it is the difference between two mating parts. Okay. Yes, understood.
Yes, sir.
Yes, sir.
Yes, sir.
Which part is remaining? Yes. Okay, so we will move toward the next part. Okay, means up till now we have covered here limit and tolerances. Okay, then our next part, our next point, it will be the pit. What is meant by the pit? Okay, what is meant by the pit? Yes, anybody having any idea what is meant by the pit? What is meant by the pit? Tell me. Yes. What is meant by the pit? Yes, anybody? Hmm? Akanksha, Asbe. What is meant by the pit? Pit is nothing but here that pit concept. It will indicate the it will indicate the tightness. It will indicate the tightness or tightness or the looseness of metal parts. Tightness or the looseness of metal parts. Metal parts. Okay, the fit is nothing but it indicate the tightness. It indicate the, it is important point. It indicate the tightness or looseness between two metal parts. For example, okay, again take the example. Suppose say this is your hole is there. Okay, this is your, it is visible to all. Yes.
Yes,
Yes.
sir.
See, this is your hole is there, and suppose this is the shaft. Okay, when I have inserted that shaft into the hole, okay, then whether it is showing the tightness or looseness, whether it is showing the, it is a tight or loose,
Looseness.
it is showing the looseness. Okay, it is showing the looseness. Then take another example. Suppose take the another example. For suppose we are having, see, this is the hole is there. Okay, just have to imagine. Suppose this is the hole is there, and suppose this is the shaft. Okay, this is the shaft. So this is the shaft. And suppose I have inserted that shaft into this hole. Then whether it is showing the tightness or looseness.
Tightness.
Okay, it is showing the tightness. Okay. Then another example. See, this is the hole, and this is the shaft. Suppose that shaft we have to insert into this hole. Again, it is showing the looseness. It is showing the tightness. It is called as the fit. Fit will give the information to us regarding to the whether there is the tightness or whether there is a looseness. When that two parts we have to meet to each other, it is called as the fit. Okay, fit is nothing but it indicates the tightness or looseness between two metal parts. So understood? It is called as the fit. Okay, then what are the different types of the pits? What are the different types of the pit? Okay, again that pit having three types are there. Okay, again that pit having the three types are there. What are that different types of the pits are there? Yes, please tell me that list name.
Clearance fit. Transmitted.
Okay, again that pit is classified into three types. First is the clearance pit. Then next is the interference pit. Interference fit, and then third it will be the
Transition fit.
okay, it will be the transition fit. These are the basic types of the fits are there. Okay, first is the clearance fit, second is the interference fit, and third it will be the transition fit. Okay, then what is meant by the clearance fit? Okay, what is meant by the interference fit, and what is meant by the transition fit? Okay, that part we will discuss here. Again, it is very simple. Okay, first of all, we have to understand the meaning of the fit. Fit is nothing but it is showing that whether that two parts, suppose I am making the assembly of the two parts, whether that parts are fixed to each other or whether that parts are the losing to each other. Okay, that information is nothing but it is the fit. ते पार्ट कसा बसलेला आहे, एकदम फिट बसलेला आहे, लूज बसलेला आहे किंवा एकदम इंटरमिडिएट बसलेला आहे, that information will got from this fit concept. Okay, now see here, what is meant by the clearance fit? First I want to write here the clearance fit. What is meant by the clearance fit? Yes, simple काय असेल? Clearance means what? Clearance म्हणजे काय असेल?
Loose meeting.
Means what? Means suppose for example, suppose this is the hole is there, and suppose this is the hole. Okay. And in that hole, suppose we have inserted this shaft. Okay. This shaft. Okay. In between, suppose this is your shaft is there, and this is the hole is there. In between that, the whatever spacing is remaining, whatever space is remaining, that space is called as the clearance. Na? It is the clearance, na? Yes or wrong? Yes. Hello.
Yes,
Yes.
sir.
Okay. Then how we can say that here? What is meant by the clearance fit? Simple. Okay. Fan clearance fit is nothing but simple concept is there. Okay, you have to remember here the clearance fit is nothing but fan the size of shaft. Okay, fan the size of shaft. Fan the size of shaft is smaller. Is smaller and the size of hole, and if the size of hole is the bigger. Okay, if size of shaft is the smaller and the size of hole is the bigger, that time it is called as the clearance fit is there. Example, simple example we will take here. See, this is the hole is there. Okay, so this is the hole, and suppose this is the shaft. Okay, this is the shaft. This is the shaft, and suppose when we are inserted the shaft into this hole, okay, just you have to imagine. Okay, there will be a small gap is remaining here. That small gap is called as the clearance. Okay, म्हणजे जर आपण हा शाफ्ट या होल मध्ये इन्सर्ट केला तर काय होईल? पूर्णपणे क्लिअरली इन्सर्ट होईल. Okay, clearly insert hoil. It is called as the clearance fit. And what is the simple definition of for your better understanding? I'm going to write down here. When the size of shaft is smaller and when the size of hole is the bigger, this condition is called as the clearance fit. This condition is called as the clearance fit. Then in another word also we can call it that clearance fit is nothing but whether it is tight fit, whether it is showing the tight fit or loose fit. Whether that clearance fit it is showing the tight fit or loose fit.
Loose.
Okay, loose fit. It will showing the loose fit. Okay, just have to remember Then anybody having any example, please tell me. Example of the clearance speed. Yes. Example of the clearance speed. Yes. Practical example of clearance speed. कुठे पाहिले का तुम्ही? Yes. डोर पाहिले का आपल्या घराच्या समोर डोर? Yes.
Piston,
Piston and
cylinder.
suppose this is the cylinder and this is the piston. Okay. Okay, that piston, it will be easily move up and down inside the cylinder. So this is the cylinder, this is the piston. Okay, this piston, it will be easily move up and down. It will be easily move up and down into this cylinder. Means in between this cylinder and this piston, there is a small gap is provided, small clearance is provided. Okay, small clearance is provided. It is called as the clearance speed again. And tell me for this pen and this cap, okay, whether it is clearance speed, whether it is clearance speed. Yes.
Sir.
Yes, sir.
Okay. Again, it is the example of the clearance speed. This is the example of the clearance speed. Okay. Means in that clearance speed, the size of shaft it will be smaller and the size of hole it will be the bigger. Okay. That point you have to remember. The next is, okay, this is for your better understanding, huh? That actual definition we will see later on. Then next bit it will be the interference bit. Okay, next bit it will be the interference bit. And what is meant by the interference bit? Yes, anybody? The second it will be the interference bit. Okay, interference bit. What is meant by the interference bit? Again, interference bit is nothing but when the size of shaft, the size of shaft, yes, the size of shaft it will be the larger and the size of hole it will be the
Smaller.
Smaller.
small. If such condition will be there, that time it is called as the interference bit. Means here, okay, suppose this is the shaft. This is the shaft, and suppose this is the hole. Suppose this is the hole. Okay, if such condition is there, now see whether that shaft is small or hole is small is here. Your hole is small, na?
Yes, sir.
This here. Okay, this is the hole, and this is the shaft. And we have inserted, or we have to inserted that shaft into the hole. So whatever fit is generated, it is called as the interference fit. Then tell me whether that interference fit it will be the tight fit or loose fit.
Tight.
Right.
It is the tight fit. It is the tight fit. Okay, again you have to imagine in that interference fit the size of shaft is larger and size of the hole is the smaller. Then how it will be inserted into this hole? It is possible. म्हणजे समजा आपला एक होल आहे, होल छोटा आहे आणि शाफ्ट मोठा आहे. जर आपण हा शाफ्ट इन्सर्ट केला तर तो ऑटोमॅटिकली जाऊ शकेल का त्याच्यामध्ये आतमध्ये इन्सर्ट होऊ शकेल का? नाही होऊ शकत. ओके. देन टू अचीव दिस फिट, ओके, how we have to achieve this fit interference fit. To achieve that interference fit, it is necessary to apply the force. Okay, apply the force to that shaft. Means we can use the hammer. Okay, we suppose this is the hole is there and again it is the shaft is there. Okay, in this condition it is required to apply the force on that shaft with the help of the hammer. म्हणजे hammer ना तुम्ही ठोकू शकता. एक hammer घ्यायचा आणि hammer ने काय करायचं, तो shaft ठोकायचा आहे आणि त्या force मुळे काय होणार आहे, तो shaft it will be inserted होणार आहे. किंवा काय करायचं, again we can use the hydraulic pressure. Hydraulic pressure बघितले कसल्याप्रमाणे? Hydraulic pressure, we have to take the help of the hydraulic pressure. Means we have to apply the hydraulic pressure on this shaft and we have to insert that shaft into it. Or third option is we have to hit that hole or shaft. Okay, we have to hit that shaft. Shaft hit केल्यानंतर काय होतं, shrinkage होईल आणि त्यानंतर तो insert होऊ शकेल. Okay, for this purpose or in this way we can easily achieve this interference speed. So understood what is meant by the interference speed? Yes.
Yes, sir.
Then
Yes,
the
sir.
last is transition bit. Then what is meant by the transition bit? Yes. Yes. What is meant by the transition bit? Transition bit is nothing but it is the phase. It is the phase between the clearance bit and interference bit. Okay, it is the phase between the clearance bit and interference bit. See, here. Clearance bit and interference bit. Okay, you have to remember here the transition bit is nothing but it is the phase. It is the phase of clearance bit and interference bit. Whether it is showing clearance bit or whether it will be showing the interference bit. Okay, with the example we will explain here. So basic definition you understood here for the transition bit. What is the simple definition? Transition bit is nothing but it is the phase. It is the phase between clearance and interference bit. That point you have to remember. So we will take the example here and accordingly we will understand that. Okay. Okay, so I will draw here the figure and according to that we will discuss here. You can also draw the figure here, no problem. This is the shaft is there. So wait for 2 minutes. I will draw figure completely here and then we will discuss. Now see here, this will be the hole. See, this will be the hole. Okay, and this will be the, yes, this is the
Shaft.
shaft is there. This is the hole. Now see here. And now see here, what is this? See, this is the tolerance zone. This is the tolerance zone for the polar shaft.
Hole.
Hole.
This is the tolerance zone for the hole. This is the tolerance zone for the hole. And tell me, what is the, this is the tolerance zone for the,
Shaft.
this is the tolerance zone for the shaft. This is the tolerance zone for the shaft. Okay, see, this is the condition number 1. This is the condition number 1. Okay. Then the next figure also immediately I will draw. Okay. Imagine, suppose this is the shaft now. So this is the shaft is there and this is the hole is here. Then tell me, what is the tolerance zone for the shaft and hole? Please tell me faster. Whether this is the tolerance zone for the,
Hole.
so this is
Shaft.
the this is the tolerance zone for the shaft,
Shaft.
and this is the tolerance zone for the,
Hole.
Hole.
this is the tolerance zone for the hole. Okay, this is the condition number 2. Okay, then tell me whether it is the example of which fit is there. Yes, whether it is clearance fit, whether it is interference fit, or whether it is transition fit.
Clearance fit.
It is the
Clearance.
clearance fit.
Clearance fit.
Okay, then it is
Clearance fit.
the second number. Yes, it is the
Interference.
it is the interference fit. Then from this figure, can anybody tell me what is the definition of that clearance fit? How we can write down their definition? Yes. Now
Size
simple.
is smaller than hole.
No, this is very simple. But from this tolerance zone, we have to prepare the definition here. Now see here the tolerance zone of hole. Okay, I'm going to write down here the tolerance zone of hole. The tolerance zone of the hole is above the yes, above the tolerance zone of yes, above the tolerance zone of
Shaft.
shaft. Okay, it is called as the clearance fit. Now see here, see this is the tolerance zone of the hole, and this is the tolerance zone of the shaft. And just see the figure, you can easily understood the tolerance zone of the hole. The tolerance zone of the hole is above the tolerance zone of the shaft. This condition is called as the clearance fit. And here for the interference fit, what is the definition? Yes, the tolerance zone of the tolerance zone of yes, the tolerance zone of hole is the tolerance zone of the hole is the yes. See now, this is the tolerance zone of the hole and this is the tolerance of the shaft. Then how we can prepare the definition? The tolerance zone of the hole is
Below.
correct. It is correct. Below the
Tolerance zone of shaft.
tolerance zone of the shaft. It is called as the interference fit. So understood? आता मला सांगा ह्याच्यामध्ये how to show that clearance fit in graphically manner. Now see, this is the tolerance zone. This is the tolerance zone of the hole, and suppose this is the tolerance zone of the shaft. मला सांगा टॉलरन्स ऑफ झोन ऑफ द होल हे अबो पाहिजे का बिलो पाहिजे? हे बरोबर आहे का? बरोबर आहे का?
Yes, sir.
Okay.
Yes.
It is called as the clearance fit. And here how to show that interference in graphically manner. Suppose this is the basic size or zero line. Okay, now tell me, this is the tolerance zone and this is the tolerance zone. Then tell me, what is this tolerance zone? This is the tolerance zone for the yes. This is the tolerance zone of shaft or hole?
Shaft.
It is the shaft, and this is the tolerance zone for the hole. Now see, it is very simple. समजते का? सिंपल आहे का? हे कसं लक्षात ठेवायचं आहे? Now here clearance fit is nothing but okay, first upon you have to remember in that clearance fit shaft size is smaller and hole size is the bigger. In definition, okay, the tolerance zone, see the tolerance zone of the hole is above and the tolerance zone of the shaft is below. It is called as the clearance fit, and vice versa here in the interference fit, the tolerance zone of the hole is below and the tolerance zone of the shaft is the above. It is called as the interference fit. Then tell me the example. What is the example for the clearance fit? Okay, example for the clearance fit. Distance cylinder arrangement घ्या. त्यानंतर आपल्या म्हणजे घराची काय जी काय दरवाजा असतो त्याची कडी पॉइंट म्हणतो का? कडी पॉइंट कडी आपण एक लॉक करतो का? लॉक. It is called as clearance fit. And then what is the example of the interference fit? What is the example of the interference fit? Yes. What is the example of the interference fit? Dowel pin. समजा आपल्याला कसा होल असेल आणि होल मध्ये एखादी पिन आपल्याला इन्सर्ट करायचं असेल तर डॉवेल पिन आपण सिंपल त्यामध्ये ठेवायची आणि सिंपल हलकासा जर फोर्स दाबला ओके सॉरी द एक्झाम्पल फॉर द इंटरफरन्स फिट इज द whether you have seen the ceiling fan in our home, ceiling fan, whether you have seen the ceiling fan, Yes.
Yes.
Okay, now see, suppose this is the, so this is the pen. This is the pen and this is the one rod is there. Okay, that rod we have fixed right to the your structure. And here, see, this is called as the shaft, and here one bearing is there. Okay, one bearing is there. Okay, here one bearing is there, and okay, here this arrangement, this shaft and this bearing arrangement, it is in between that there will be the interference fit. A tight fit asnar. Okay, it will be the tight fit. This is the example for the interference fit. You have to remember the example for interference fit is the ceiling fan. Okay, in our okay, जो काय वरून जी पंख्याचा येणारा तो काय शाफ्ट असतो, तो शाफ्ट कुठं आपण फिक्स केला असतो, खाली बेरिंग. ओके, बेरिंग असते त्या ठिकाणी, त्या बेरिंग मध्ये शाफ्ट असतो, तो कुठले फिट राहतो त्यामध्ये, तर इंटरफरन्स फिट. सो अंडरस्टूड? Yes.
Yes, sir.
Okay, that two fits are clear, clearance fit and interference fit. Then tell me what will be the condition for the transition fit. Transition fit मध्ये कसे असणार आहे दोन्ही झोन? The tolerance zone of the hole and tolerance zone of the shaft, it will be overlap to each other. It will be overlap to each other. It is called as the transition fit. Okay. Yes. Yes. Okay, that point we will discuss on later. Okay, so thank you.